So in this video, what we're going to look at is solving a system of equations by using Gauss Jordan row reducing elimination, whatever you want to call it. So we're going to use matrices is what the name of the game is. So just to kind of review what the goal is when you're solving a system of equations, the goal is to get an answer for x and an answer for y. And I'm writing it this way for a reason, but we're hoping to get a value for x, which I'm just going to call a, and we're hoping to get a value for y, which I'm going to call b. So what that means is in matrix form, so just remembering how to set up this up as an augmented matrix. With matrices, we don't care so much about the variable, we care about the coefficients because that's what we're going to keep track of. And as an augmented matrix, this would be 1, -2, 2, -3 on the left, and 2 and 7 on the right. And we use that vertical line right here to separate the variable side from the constant side. So it's just more of an organizational tool. We don't need the vertical line, but it's very helpful to stay organized. So that means that my goal is to get a matrix that looks like this. So our goal is to get ones on what we call the main diagonal going from the upper left to the lower right, and then zeros everywhere else. So the key is, how do we get there? And it's really just a set of steps that we used in elimination, okay? So the order that we go in is, we try to get a 1, or as we're going to discover later, we're okay with any number in the upper left-hand corner. It really doesn't matter what that number is. Then we try to get the 0 in the lower right-hand corner. I'm sorry, in the lower left-hand corner. And then we try to get a 1 in the lower right-hand corner. And then we try to get this 0 in the upper right-hand corner. And it is going to seem a little repetitive, but there are really big reasons why we do it this way. Okay, so what I'm going to do is, I notice I have the 1 in the upper left-hand corner, so this is good news. And what I'm going to do is say, well, I need to get this to be a 0. So if you think about how elimination works, it really works the same way. But I'm going to call this R1, and I'm going to call this R2. And I want to rewrite R2 so that it has a 0 in the left-hand corner, in the left-hand side there. So that means that I am keeping R1 the same, and I'm changing R2. So think about elimination. With the original system of equations, I want to get rid of the x in the second equation. So I'm going to multiply the first row by -2, and I'm going to add it to the second row. And what I'm going to do is make that the new R2. So -2 times row 1. Well, -2 times this row right here just means I multiply each number by -2. So that means I have -2, +4, -4, and I will put the vertical line there just to be consistent. And I'm adding that to R2, so that's 2, -3, 7, and my new R2 is 0, 1, 3. So that is going to go here. So I'm going to draw that in red. 0, 1, 3. Now, if you look at our goal, we already have the lower portion of this done. So all that matters now is to get the upper right-hand corner to be a 0, and then whatever's on the right-hand side is our solution. So this is good. We're almost done. So this is kind of a new R1 and new R2, but now the script is flipped. R2 is the way I want it for now. I need to use it to change R1. So again, thinking about elimination, this is x minus 2y equals 2 and y equals 3. So if I'm using elimination to rewrite that, I want to take 2 times the second equation and add it to the first. So I'm going to say, I'm going to say 2r2 plus R1, and that is going to replace R1. I want that to be my new first row. So 2 times R2, and again, keep in mind, I'm using this matrix now, because this was the next step. So 2 times R2 is 0, 2, and I'm going to draw the vertical line again, and that's 6. And R1 is 1, -2, 2, and I get 1, 0, 8. So putting that all together, my final matrix is, so my new R1 is 1, 0, 8, and R2 was 0, 1, 3. And what that tells us is that x is 8 and y is 3. And if you want to substitute those in the original equations, you will notice that they both work. So there is our first example using Gauss Jordan. Definitely stay tuned for more.